Hello everybody, welcome to STN-Bit. In this channel we discuss network automation and programmability concepts. In today's video we are going to extend our Containerlab playlist by exploring additional features that we have with VSCode Containerlab extension, and obviously I'm going to show you how to use wireshark to inspect packets within our lab network. Alright, let's go ahead and begin. I am going to open up my terminal, and as you know from my previous videos, I already have a GitHub repository where I push all my changes after each video, and I will obviously drop the link to my GitHub repo so you can clone it and work on the same files as you please. Now, I am going to open my local GitHub repo, which is called Lab21, as you may recall from the previous videos. And as you can see, at the moment, we do not have any changes that we need to sync, which means our directory is clean and we can begin working. First step, obviously, is always enabling or activating the Python virtual environment just to make sure we're working without getting other Python packages dirty. So my Python virtual environment is called .vnetauto, as you can see here. I am going to activate it. So activate, done. As you can see on my right side of the screen, it is activated. The other way of activating, of verifying if it's activated or not, would be by running which Python 3 command, and it will show you the path to virtual environment folder. Cool. So now let's create a new directory. Let's call it demo or demo, and let's basically do all our changes, make all our changes within that directory. I'm gonna switch to that directory. Good. Okay, so since we're going to use VSCode extension of Containerlab to demonstrate these features in this video, I am going to actually open up VSCode right away. So I'm opening it up. It requires authentication. I am going to type in my password real quick, and we're in. So I'm gonna go ahead and open my newly created demo folder right away. It should be under Lab21 directory, demo, open, done. It's a free directory, obviously, there's nothing inside yet. And we are going to create files. The first file, obviously, we need to create is the topology definition file, which consists all the nodes and the links that we want to deploy within Containerlab. So let's call it basically demo.yaml, a very simple name, and I'm going to populate this file with with appropriate structure that you can also find on Containerlab's official website, which is containerlab.dev. All right, so let's go ahead and actually populate this file. Obviously, we start with name object. Let's call it demo. I am always using prefix option with an empty string because I don't want additional CLab name in front of my file name. It makes file name longer. Then obviously I'm going to mention topology because we are basically creating a topology, a network topology, and the first element is obviously nodes. So as you can see, my VS Code suggests me to, do these nodes and automatic prompting and everything, but obviously in our videos we're using Arista CEOS images. I do not use anything related to default Nokia SR Linux, but of course if you have those images, if you prefer to work with those images, you can do the same thing on different vendor instances. All right, so in my case, I am going to create, let's keep it simple. We're going to create a simple network consisting of 2 switches and 2 hosts, right? Very simple network, nothing fancy. Let's call it switch 1. In my case, it's going to be CEUS. The kind will be CEUS, which stands for Containerized EOS. And I already have my image. If you remember from the previous videos, I already have my Arista 4.34 image. I can actually show you here by running docker images file commands. So this is the one we're going to use for this video. So I'm gonna just specify it right here. It's gonna be 434.1f, and basically, yeah, I will do one more thing, which is basically disabling automatic management network that is being created by Containerlab. So by default, Containerlab creates this management network for each nodes and connects them to Docker network so that we can access devices via SSH, so we can reach the outside world and everything. But I don't want that. I want fully naked nodes without any extra configuration on it. We're gonna connect to our nodes by console, and then we can configure them for SSH access or anything else. So to accomplish this, there is a command. It's called network mode, not command, but like a line that you should add. It's called network mode none. So none means nothing. Do not add any extra network related config to the devices that you are going to spin up. Okay, so I'm going to do the same thing for switch 2. Alright, it should be pretty straightforward. If I just hit tab, it should give me the same thing. Exactly, that's cool. And now let's create our host objects. So host 1, in my case it's going to be kind Linux, of course. I am going to take Alpine Linux because it's much more lightweight. Let's take the, sorry about this auto-completion thing, it can get dirty. I'm gonna take the latest version of Alpine, alright. And again, network mode none, because I don't want any config on it, because I will specify config myself. I will create 2 more files to accommodate configuration, the initial configuration or startup configuration, if you may, for these hosts, because it's just easier to add static IP addresses for these Alpine hosts. Otherwise, they will not be able to ping anything. So the same thing for host 2, I believe, so far, and that looks good for now. Now we can go ahead and create the second object of topology, which is basically links. And under links, it's pretty straightforward. It gives me some connection. So let's say host 1 is being connected to switch 1, host 2 to switch 2, and then there is interconnection between switches, which makes perfect sense. It looks good. It looks really good. So I don't know if I should change that. It looks really good. I'm going to keep it this way. Now what I'm going to do is I am going to create basically a new folder, and I'm going to call that folder configs or CFGS. Again, I will drop the link to, actually, let me just show you, it's going to be easier. I am going to open a new window and go to Containerlab's official website. And here, if you actually go to, you can just search for config. I think we should have some, yeah, this section, configuration management. In this section, there's this small, let's say, example of how you can create your configs, the startup configs, and store in the same directory. So basically, this is what I followed. So we're going to create a CFGs or configs folder, and under this folder, I am going to create the host names for our Alpine files. So in my case, it's going to be, so we have host 1 and basically host 2. Yeah, I'm just gonna name them accordingly. So host 1 dot, let's actually see it, partial.cfg. Well, in our case, it's not really partial, is it? It's just, we can call it basically network.cfg. That works all right. And the same goes for host 2. So host 2 network.cfg. Cool. So here is our directory, and here are our startup config files for our hosts. Now, to bind these config files to our nodes that we want to spin up under this lab, we need to use a bind option, which is, I'm not sure if it's specified here. Let me search for it real quick. Yeah, not really, but yeah, anyway, I'm going to show it right here. There's no need for anything else. So it's called bins. We're going to go to under host 1. We're going to say bins, and we have to specify the relative path to the directory where we store our basically host configs, right? So in our case, it will be CFGS, sorry about typo, and then we have host 1. I'm going to, yeah, just specify the full name of the file, which is host1 dot, sorry, there is one typo here as well, it should be dash. Alright, and we are basically going to say etc network interfaces read write. So we want to be able to bind the startup configuration file, which is located under CFGS directory, to, so this column basically binds this first part to the network interfaces file within our Alpine Linux instance, right? And then we are going to execute, basically we're going to execute command which will bring up the interface Ethernet 1 up, because we're connecting interfaces Ethernet 1 on both hosts to the switches, so we must make sure they are up and running, right? So it's going to be exec, and we can actually do it like this. Well, in our case, we don't use CMD. I'm going to delete this. In our case, we can just say bin. Sorry about this. Okay, bin and sh or ASH, but I'm going to use sh, which is basically shell. It's like connect to the shell, and -c stands for command, and issue this command in the shell. So if up means interface up, bringing interface up. Alongside, I am going to mention sbin in it so that it retains the configuration even if we reboot those hosts. Okay, so that should be enough to bind and execute our file, but I just have to yeah, fix the indentation issue. Sorry about that. And the same thing basically will be pasted to host 2, and they will only modify the host name accordingly, which is host 2 in this case. And configuration wise, we have to put the config here, so it's pretty simple for Linux. First of all, obviously auto Ethernet 1 to make sure that it retains the interface specific configuration. Interface, yeah, it works. Address, I'm gonna give it let's say 172.31.10, and the net mask, let's say /24. Why it does not yet allow me this auto completion feature with VSCode is it's a bit weird sometimes. The same thing will be copied to here, and we'll change the static IP to, let's say, 20, right? So that's pretty much it here. It's a very simple startup config file for Alpine hosts. Obviously, we can create a similar type of files for our switches, but we can do it via CLI, so this is just a simple demo. It shouldn't take so long. Alright, so everything looks okay to me. I'm going to save this file. As you can see, again, let's just quickly go over this file. We have the name, the prefix, which allows us to shorten the name, topology, element consisting of nodes and links. And by the way, I just realized I must fix indentation here as well. It doesn't look correct. Now this looks correct, because yeah, this looks correct. I'm gonna save it again. Yeah, we have switch 1, we have switch 2, Arista COS instances, we have host 1, host 2, Alpine Linux instances, and we have specified 2 startup configuration files for our Alpine hosts. And when we deploy the lab, it should ideally bind the startup configs to the interface config of the actual Alpine instance and execute following command set to bring up the interface and make everything ready for us. Now it's the best part. We're going to attempt deploying this lab. So yeah, as you can see, our file is here and our config directory is here. So let's go ahead and deploy, but before I'm just going to confirm the version I'm running currently. It's 0.69.3. Cool. And let's go ahead and try to deploy this thing. So it's clab deploy -t demo.yaml, and the deployment has started. So it looks okay so far, but there's this weird line: fail to disable TX checksum offload for Ethernet serial interface for host 1, which is expected because we did not want it to have any configs. So we put the network mode none, so we don't want any config on it. Anyway, we're gonna wait, and it looks like it's done. Our lab has already been deployed in a matter of seconds, and as you can see, all our hosts, all our nodes are running, and they do not have any IPv4 or IPv6 address. Again, why? Because of this option here. Because I wanted them to start up naked without any IP configuration on them, unless I specify it myself, which I did with these files here. All right, so now let's go ahead and connect to our nodes by console, right? So I'm going to open up a new tab, and I'm going to say docker exec-IP. I'm going to specify the name of our host, let's say host 1, and I'm going to connect to the shell. Cool. And now if I say IPA, I should be able to see Ethernet 1 interface being up and with an appropriate IP address that we have specified in startup config. I'm going to hit enter, and indeed it was successfully auto-configured, which means our bins and exec commands worked properly. So I'm going to do the same thing for the other host. So docker exec-it host 2 shell, again IPA, and again everything looks good. The state is up and the IP address is here. So now we can go ahead and play around. So let's also connect to the switches. All right, let's connect to switch 1. Again, docker exec-it switch 1. In this case, I'm going to say bash because Arista EOS uses bash shell, and we are in bash shell of our switch. We can run an uptime command just to confirm that it shows it was up for 27 minutes, which is weird. It should not be up for 27 minutes. I just loaded up. I just deployed the lab, but maybe it's talking about the image, the Docker image. Weird. Anyway, so now that we have connected to our switch via console to the bash shell, there is a command which allows us to switch to CLI mode for Arista, and it's going to be CLI, C as a capital letter. You can enter here, that's going to work, but if you specify -P15, it will give you the maximum privileges. Basically, -P stands for the privilege. So your user will have the maximum privileges. Enter, and as you can see, I have directly opened the CLI to the privileged execution mode, right? So this is our switch. I'm just going to run some commands, show version. Uptime is 3 minutes here, which makes sense, unlike this guy here. So it's probably uptime of something else. Yeah, happens. Anyway, so let's do the same thing for switch 2. Again, docker exec-it switch to bash CLI-p15 show version. Yeah, there we go. So now we have the console session to all of our nodes, and they do have an IP address. And let's go ahead and start poking the topology, viewing, and wireshark and everything. So if you go to Visual Studio Code, you will see this Containerlab extension. Now, I have showed you how to install it, how to download it and install it on previous video, but basically it's very easy. You just go to this extensions section and you just type in Containerlab, right? And this is it. You just hit it, download or install whatever you have, and then you have it. Then you will have it right here, and you will open it. And as you can see, it shows me the current state of my lab. There's a green LED kind of icon, which means currently this lab is up and running. So if I maximize it, I will see each of my hosts, their uptime, and if I maximize the host, I will see the links that are up and running, right? So now the interesting part is basically, if you hit this name of the lab, you will see an automatically generated topology of our lab, which is very cool, which is very structured. It looks solid, it looks simple. We have our host 1, host 2, switch 1, switch 2. We have the interface names, we have the links specified with green color. Probably it's green because it's up and running. We can play around and we can actually test that out. Let's actually do it. One of the things that Containerlab extension provides also, like, you have direct shell, which is console session, or SSH session to the devices. Let's try to SSH. Let's try to connect the shell from the VSCode. I'm gonna hit this attach shell command for switch 1, and it is connected. So again, I'm gonna say CLI-p15. I am on CLI mode now, and let's play around. Let's disable this interface. Let's shut it down. Let's see how topology viewer will react. So I'm gonna go to interface. I'm gonna go to configuration mode, of course. Say interface Ethernet 2. I'm actually gonna give it a description. This interface goes to switch 2. All right. Show active will show us the current config on it, and then let's basically shut it down. Did this become red? Maybe I over expected. Actually, I can close it and open again. Yes, it did. It indeed did. Well, it became red because we shut it down. And if I say no shutdown to enable it again, now we should have some other command. I'm going to maximize, what is it? Fit to viewport. So we have toggle YAML split view, find node, capture viewport as SVG, which is pretty cool. You can actually save your topology as an SVG file and share it with your peers. And then, yeah, about top of viewer, a very useful feature thanks to developers of this feature. So I'm just wondering, how can I update the thing? Wait, how can I just refresh this? I'm trying to find something related to it, because maybe here. Yeah, I don't see anything. Anyway, so again, we can just close this tab and reopen. Yeah, it's green again. So what else you can do here? The most interesting part, of course, as I mentioned at the beginning of this video, is wireshark packet inspection. Now, there are multiple ways of doing this. So basically, you can just maximize these nodes here, and you can see their links and their states, and you can see this shark icon. So I forgot what was the name of this part of the shark. Let me actually the shark part, upper part name, shark upper part name. It had a name, I just forgot it. It had a fin, right? A dorsal fin. That is what they call it. So basically, yeah, if you see this fin icon here, you can directly just hit on it, click on it, and it will capture the interface state. But what you can also do, you can also come to the topology, and you can, let's say, just hit the right click, and then it will show you two options. So you can either capture the interface state from the switch side for this link, or from the host side. Let's capture from the switch side. I'm going to hit the switch side, and as you can see on this part, it's starting the wireshark and the edge shark. Now, when you run it first time, it will pull the edge shark and all related files automatically from their repos, and will install it automatically as well. So you might need to wait a minute or so. But anyway, as you can see, it has already opened. So I'm just going to close this part and minimize this part so I can show you what's going on here. So this is basically switch 1's interface that looks towards the host 1. And as you can see, it already started to capture the packets. There are a lot of spanning tree packets going on because sorry guys, there was an interruption on my operating system, and my previous video has stopped abruptly, and basically now I am recording again. This is the continuation of the previous video, and yeah, let's just continue discussing. So yeah, we were basically talking about packet inspection within interface Ethernet 1 of switch 1, and yeah, as you can see, we can already see a lot of STP packets on this link. Now, yeah, we can obviously keep touching them, we can take a look at them, but just for the sake of simplicity, I am going to disable spanning tree on our switches so we have a better view of what's going on. Of course, by default, Arista US enables spanning tree. So to override this behavior, I'm going to disable it using spanning tree mod non-command, and it will stop after I do the same thing on the second switch. So I'm gonna open a shell session to it as well. Again, we're going to say CLI-p15 conf, the same command, spanning tree mod none, and currently it's still increasing. So if I hit enter, it should stop incrementing, and it did stop. So the last STP packet was number 82. Now it's cleaner. We should see nothing but LODP packets only, because LODP is also enabled by default on Arista US instances. Now, if you want to stop it as well, you can run no LODP run commands, but I'm just going to keep it because it's not as frequent. It doesn't hurt, right? Cool. So now what we can do is we can basically, if we go back to topology, we can actually observe another link. Let's say switch 1 is a net 2. I'm going to open up another wireshark tab for this. And now we can observe some basic packets. Let's say ARP packets, right? So let's make sure our switch MAC address tables are empty. So show MAC address table. Let's clear MAC address tables. Dynamic. Let's do the same thing here. Cool. And let's open the shell session to our hosts. So host 1 and host 2 as well. Now on host 1 again, confirming the IP 30.1.10. On host 2 it should be 30.1.20. And now let's try to send ping from host 1 to host 2. It should generate some there was some issue with this, so let's try the other part. Let's try switch to Ethernet to interface. Yeah, it looks much better. Yeah, so it should display some ARP packets if we initiate the ping. So I'm currently on host 1, I'm gonna ping host 2. So 172.31.20, and ICMP packet started flooding because we're sending ping. What about ARP? Yeah, we have some ARP as well. We can stop and we can basically observe. So yeah, it's a basic ARP packet, but it already knows the destination, which means because I've tried it before. So I'm gonna try to clean the ARP cache on devices, or maybe on the switches. Clear, I don't know if we have a command for it. Clear ARP, no. Clear ARP, like bridged maybe. Show ARP. Yeah, I'm not sure if bridged was the right command, but the ARP cache is empty anyway. Yeah, it's empty anyway, so it wasn't the right thing anyway. So it needs to be removed from here, but let's see. What is the right command? Yeah, it already has it, so can we just remove it from here? I would need to know the command. Oh, -d, okay, then we should specify, okay, let's specify the IP address then, -d 172.31.20, okay, now it should help. I'm not sure if the same thing should be done on host 2. Well, I basically just want to inspect ARP broadcast packet. Yeah, the same thing needs to be done here as well, of course. So 172.31, good. Now, if I initiate the ping again, because we have cleared the ARP cache on both hosts, we should be able to see some ARP broadcast requests. I am going to ping again, and yes, I have seen it. If it is enough, I can stop, and there you go. So this is ARP broadcast request. Basically, if we can do everything here like the same way we do with wireshark software itself. We can check the Ethernet frame, we can check the protocol information, the fields of all these packets, all right, and we can see that we're sending a broadcast request to this broadcast address within the broadcast domain to understand who is owning that IP address, which MAC address it correlates to, and then our sources, basically our interfaces are not one address, so it ends with 7E:EE. This is it, and if we continue observing, if we go back here, we have received a response indeed from basically this MAC address, which should correspond to the MAC address of host 2, and then we go to host 2. If we check the MAC address here, indeed it's 29-91. All right. Okay, so yeah, we can also take a look at this ICMP ping request. Again, we can double click on this packet. It will give you, for example, IPv4 field information. What we have here, we have the source IP, we have the destination IP, TTL, fragment offset, don't fragment bit is set to 1. Yeah, basically if you are working with these type of configurations, if you want to see this packet level on your lab without having extra installations or extra, let's say, steps, and in a very quick way you can use Containerlab extension and just click on this, the dorsal fin of a shark, and then it will capture the interface and show you everything. This is very cool and very useful feature of Containerlab. I really appreciate developers working on this. I think for today it is enough. I really wanted to keep this video short, but it still took some time. So we're gonna continue with these type of videos, and yeah, see you on the next video. I'm gonna continue exploring Containerlab. We're gonna do it together, and if you have any questions, please don't hesitate to drop them under the comment sections. Thank you very much for viewing my content, and see you on the next video. Bye.